quite following me yet, don't worry. We're going to take a look at an example. Let me show you what this process looks like. For this example, our multivariable function f of xy is equal to the square root of 9 minus x squared minus y squared. All right, now you could rewrite this function using the dependent variable. You could say that z is equal to the square root of 9 minus x squared minus y squared. What we're going to do here is essentially that, but instead of z, we're going to set the function equal to a constant c. All right, so we'll say c is equal to the square root of 9 minus x squared minus y squared. And then from there, you could choose different constant values to plug into that c in this equation and then try to graph it. But to make that process easier for us, because I currently don't know how to graph this function in its current state, what you want to do is get this equation, now that you've set it equal to c, get it into a form that you do know how to graph before you start plugging in values of c. Okay, so what I'm going to do here is manipulate this equation a little bit. If you square both sides of the equation, you'll have c squared is equal to 9 minus x squared minus y squared, right? Squaring both sides gets rid of this square root over here, and then you just have c squared on this side. And then what I'm going to do is add x squared and y squared over to this side of the equation and subtract c squared from this side. So I'm going to move it over to this side of the equation. And what you'll be left with is this: x squared plus y squared equals 9 minus c squared. Okay, once again, I subtracted c squared from both sides of the equation, and then I added x squared and y squared to both sides. And so this is what you should get. And this right here is the equation of a circle, right? You have x squared plus y squared is equal to some constant value, which would be the radius squared. Okay, remember, c is just a constant, so what's going to happen over here is you're going to plug in some value for c, square it, and subtract it from 9, and you'll just have some constant equal to x squared plus y squared. That is the equation of a circle. All right, so what this tells us is the different level curves that we're going to get, they are going to be circles that just have different values for the radius. All right, our level curves are circles. So let's take a look at some of these level curves. We want to pick some constant values to plug in for c, but you have to make sure to pick some that make sense. So remember at the beginning, c is equal to the square root of 9 minus x squared minus y squared. A square root is never going to output a negative value. In other words, there will be no negative outputs for this function. Those negative values would not be included in the range for this multivariable function. So don't pick any negative constant values to plug in for c in this equation. All right, so be careful about that. But what we can start with here is just c equals 0. The square root of a function can be equal to 0. So let's look at the level curve when c equals 0. We're going to have this equation, but where c is 0. 0 squared is 0. You're subtracting 0 from 9. So you're just going to have the equation x squared plus y squared equals 9. All right, so when c equals 0, this is the equation that we get. It's just a circle with a radius of 3, right? X squared plus y squared equals the radius squared, and 9 is 3 squared, so the radius is 3. That's one level curve. Let's take a look at another one. I'm just going to increase my c value by 1. So let's look at c equals 1. What would the equation for that level curve look like? If you plug 1 in for c here, you'll have 9 minus 1 squared. 1 squared is 1. 9 minus 1 is 8. So you'll have x squared plus y squared equals 8 for the equation when c equals 1. That will be our next level curve. X squared plus y squared equals 8. In that case, the radius would be the square root of 8. I didn't write this down before, but I'll write it down now. Last time the radius was 3. This time the radius is the square root of 8. And then let's take a look at another level curve. You're going to want to look at least 3 or 4, if not more, when you're sketching these contour maps. So don't just stop at 2 level curves. Try to find 3 at the very least, but in most cases you're going to want more than that. And so when I pick my next value of c here, I'm not going to skip by a bigger amount than I did last time. I want to try to choose values that are evenly spaced. So we went from 0 to 1. Let's go from 1 to 2. All right, c equals 2. When c equals 2, plugging 2 into our equation here, 2 squared is 4. 9 minus 4 is 5, so you'll have x squared plus y squared equals 5. All right, so this time around, our level curve is represented by x squared plus y squared equals 5. So in that case, we have a circle with a radius that is equal to the square root of 5. Once again, all of our level curves here are going to be circles, but just with different radii. But then let's find another one. Let's look at c equals 3, which is actually the biggest value of c that we could pick for this problem. Because if you think about this function here, you're taking the square root of 9 minus some value that results from x squared plus y squared, right? You could pull out a negative here and you'd have 9 minus x squared plus y squared. The smallest value x squared plus y squared could be is 0, because x squared plus y squared is always going to output a positive value. So the smallest it could be is 0, meaning the smallest number that would be subtracted from 9 is 0. And so the square root of 9, which is 3, is the biggest output for c. Okay? It's just like thinking about the range for your function like we did in the previous lesson. All right, but when c equals 3, you'll have 9 minus 3 squared, which is 9 minus 9, which is 0. So our equation is x squared plus y squared equals 0, which is a circle with a radius of 0, which means it's just a dot. It's just a point at the origin of the xy plane. And so now we have all the equations for the level curves that we're going to use to help us visualize this surface. What we want to do now is graph each of these level curves in this xy plane. And so let's start by graphing the level curve for c equals 0, which will just be a circle that has a radius of 3. So if this is y equals 3, x equals 3, y equals negative 3, and x equals negative 3, that level curve will look something like this. That would be the level curve when c equals 0. Moving on to our next level curve, for c equals 1, we have another circle, but this time the radius is the square root of 8, which as a decimal is approximately 2.83. And so that will be the radius of this circle. And so if this is y equals 2, x equals 2, y equals negative 2, and x equals negative 2, a radius of 2.83 will get close to 3 in each direction, but not quite get there. All right, so that circle might look something like this. And so that circle would be our level curve for c equals 1. Now moving on to c equals 2, we have another circle, but this time with a radius of the square root of 5. And as a decimal, the square root of 5 is approximately 2.23. And so a radius of about 2.2 would take you a little bit above 2 in each direction. All right, so that circle might look something like this. That circle would be the level curve for c equals 2. And then finally, we have one more level curve for c equals 3, and this is probably the easiest one to graph. It's not really a circle at all. The radius is 0, so it's just a point at the origin. All right, so I'll plot a point at the origin, and that would be the level curve for c equals 3. And that's it. That is a completed sketch of a contour map for the surface represented by this multivariable function. This contour map gives us a top-down view of our surface where we're looking at different traces of that surface at different values of z, those constant values that we chose to plug in to this equation to get our different level curves. And so you can see now that from this perspective, the lines are closer together towards the outside of the surface, and they are more spaced apart as you get closer to the center of the xy plane. So this surface is steeper around the edges and a little bit more flatter towards the center, at least from this perspective. All right, now you may have been able to guess, based on this contour map, along with the form of this function, that this represents half of a sphere, or a semisphere. And so just to compare the actual surface to our work here, here's a 3D render of that semisphere with some different level curves graphed on top of it. I included a few more than what we graphed in our contour map, just to give you a better visual, but we didn't have to do that in our sketch. As long as you pick values of c evenly spaced apart, you're fine. But you can see that if you were to look at this semisphere from the top down and only look at the level curves, that you get a very similar contour map to the one that we drew here. All right, so hopefully that helps you make the connection between the actual surface represented by our function and the contour map that we drew using level curves. Okay, so that's it for this initial demonstration of sketching a contour map. We're going to take a look at a couple more examples